Hello, this is a recording for Unit 3, Lesson 9, Session 3. And what we are doing today is we are focusing on graphing a linear equation of the form y equals mx plus b. So by the end of this lesson, you will be able to be given an equation in y equals mx plus b form and graph it. Let's go. Before we begin, question is, what are some things that are the same between some of these lines and what are some things that are different? So go ahead and pause the recording and identify some similarities between a couple of lines and some differences between a pair of lines. All right, what do we spy with our little eye? Well, I spy that line A is parallel to line B, which means that A and B have the same slope because notice they are increasing at the same rate. They each have a slope of 1. We're going up 1 over 1, up 1 over 1. Notice on A, up 1 over 1, up 1 over 1. What is different about A and B? Their slopes are the same, but I spy that their y-intercepts are different. Notice A has a y-intercept of 4, B has a y-intercept of 0. Let's look at another pair of lines with some similarities and differences. What about B and C? What is the same about lines B and C? Notice their y-intercepts are the same. They intersect the y-axis at 0, 0, 0. They both go through the origin. What is different about B and C is their steepnesses. That means their slope is different. B has a slope of up 1 over 1, up 1 over 1, so a slope of 1. C's slope, find 2 points on C. If we go up 1 over 2, up 1 over 2 to find the next point on the line. So B and C have the same y-intercept, but different slopes. Let's look at lines C and D. Did you notice anything the same or different with those two lines? I'm noticing that the slopes are the same. Because these two lines are parallel, they're going up at a constant rate. One will never cross the other. Let's see, up 1 over 2, up 1 over 2. Same thing with C, up 1 over 2. So C and D have the same slopes, different what? Hope you said it out loud. Different y-intercepts for C and D. Y-intercept for C is at 0. D's y-intercept is down at -2. All right, here's the situation that we are working on, and this aligns with page 209. So be on page 209 in your book. And the situation is we have a 60-gallon rain barrel that is underneath a downspout. So it's catching all that awesome Washington rain water going into the barrel. Elena opens the stopper to let water drain out to water her garden. The equation y equals -3x plus 60 can be used to find y, the number of gallons of water left after the barrel drains for x minutes. What are we trying to find? What are we comparing? We are comparing, what are our two variables? I like to circle them. We're keeping track of gallons, the amount of water, over time, over minutes. And that relationship is given by this equation, y equals -3x plus 60. So here is your equation that relates gallons of water to minutes. We know a lot about a situation once we have been given the equation. This number added to the end, notice if you squint really hard, we have it in the form of y equals mx plus b. That number added to the end represents our y-intercept. It's where our graph is going to cross the y-axis. Plus 60. Where did we see 60 in our original problem or our original situation? That was the capacity of the rain barrel. The water was all the way up to the top at 60 gallons. Elena is unplugging it. The water's starting at 60 at time 0, and it's going to be decreasing. At what rate is it going to be decreasing? The equation tells you right here. This -3 means that's our slope. Our water is decreasing at that rate. Let's look at that a little bit closer. Rate compares quantities to variables, to things that are changing. So if my slope is -3, that means our water is going to go down 3 gallons for every minute that passes. So down 3 over 1, down 3 over 1. That's coming out pretty quickly, actually, if you think about that. Okay, our task on here is to graph the equation. So before we do that, we need to make sure that we know what variables we're going to put on which axes. So we have this glorious, glorious axes here, and I wish with these tools that I had a straight edge. I do not, but you do at home. You have a straight edge, so you can use a straight edge at home and draw in your X and your Y axes here. And we are going to keep track of minutes along the X axis. And we are going to keep track of gallons, or the height of the water on the Y axis. All right, so this is our Y axis, this is our X axis, and I'll draw them in even though they're not perfect. I'm so sorry. All right, so you can see my axes here. All right, this point right here, super special, 0, 0. Is 0, 0 going to be on our graph? At a time 0, is the height 0? No. So 0, 0 is not going to be on our graph. So you know what I'm going to do is I'm going to actually delete that because I don't want it to look like there is a coordinate pair there. But it is important for you to recognize that that is your origin. All right, let's set up our scale. So what are we going to count by? Let's leave minutes alone for a minute and let's focus on gallons. It's going to start up at 60. So if I want 60 to be at the very top, how many lines do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What if we counted by something friendly like 5? Would 5 get us up to 60 about up here if we want to use a lot of our graph? Let's try. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Good. Gives up here, that means our graph will take up a lot of our axes we've been given. I like that. So let's count by 5s. Really important when you're graphing that you take the time to carefully draw in your scale tick marks and you label your axes. 40, 45, 50, 55 helps you with accuracy and precision. So we're keeping track of gallons there, keeping track of minutes over here. Reminder, it's going down 3 gallons every minute. So question is, let's do some math. Oh, we need to go up to 60, silly Miss Fergus. If we have 60 and it's going down 3 every minute, how many minutes will it be completely out? How many 3s? How many groups of 3 are in 60? 20. So with some mental math, you can figure out that we need to go over to at least 20 here. What if we counted by 2s? I don't want to count by 5s because that would only leave me about right here. 5, 10, 15, 20. Notice that's not using up a lot of my axes. Let's try 2s. I'm going to check it mentally first. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Nice. Takes us over here. That uses up a lot of our graph. All right, so we're going to count by 2s. 2, 4, 6, 8. Who do we appreciate? All right, get all those in. 16. I hope your handwriting is nicer than mine. All right, and 20. All right, now we are ready to graph. I'm going to change my color for my coordinate pairs to blue. Let's graph our first point. We know our y-intercept is up at 60. Throw in a point right up there at 60, y-intercept. Now, we're going to go down 3 gallons for every 1 minute. But that makes me so sad because I can't see a tick mark for 1. So you could estimate it, or we could come up with some multiples here. If we're going to go down 3 for every 1, aren't we going to go down 6 for every 2? So from this coordinate pair that we've just done, why is that coordinate pair not staying there? Come on, coordinate pair. Trying to get that y-intercept to stay. There it is. Okay, so for every 2 minutes, our height is going to go down 6. So I'm going to go down 6 and over 2. All right. And then I'm going to go down 6 and over 2 again. So I'm going over by 2 because I want to keep some coordinate pairs right here on these crosshairs. So down 6 over 2. Why do those things keep moving, those coordinate pairs? Oh, goodness. What if I tried that? All right, and I'm going to do another one. Down 6 over 2. It's going to be about right there. What should you notice here as you are putting in your coordinate pairs? Will it be in a curvy line? Will it be in a bumpy line? Or will it be a straight line? It will be a straight line. And we know that it's going to run completely out of water at 20 minutes because 60 divided by 3 is 20. So you can connect with your straight edge, your y-intercept here, to this special point, which is called your x-intercept. Doon, doon, doon. All right, I'm going to try and draw with this pencil again that wasn't working last time. There we go. Ooh, it worked. All right, yours is done with a straight edge, so yours will be perfect. What do these points down here mean, Miss Fergus? You drew that too far. It did. This means this is where your rain bottle has a height of negative water. Can that be possible in this situation? No. So I definitely need to make sure that my line does not go past a height of 0, because there is no way for us to have negative height for rainwater. All right, so there's our graph starting up at 60. We went down 3 over 1. You can also use multiples, down 6 over 2. What if you didn't want to do down 6 over 2? You could have tried some other multiples. You could have gone down 9 over 3. Lots of options on that one. All right. We already talked about this. Y-intercept tells you where 1 point on the line is, so you're going to do your y-intercept for that. That -3, your slope, tells you how fast the line is decreasing from there. Lines with a positive slope slant up from left to right. This is a positive sloped line. Lines with a negative slope slant down from left to right. This is a negative sloped line. This is an example of what we were talking about. A slope of -3 can be written as -3 over 1 as our rise over run. For every decrease of 3 in the y, there's an increase of 1 in x. We could also, though, use this to come up with equivalent rise over runs. So -3 over 1 is the same thing as -30 over 10. All right. Then you have these questions to complete in your book. You can go ahead and pause and complete those at this point. Let me tell you what page this is. This is page 211. Reminder, answer keys for these are available. So as you are working, there's no point in doing math practice unless you get feedback that you're practicing correctly. So do these problems on 1 and 2. All right, and we're going to do 3 and 4 together here. Explain why a horizontal line has a slope of 0. Why a horizontal line is straight across. Why does it have a slope of 0? So if we drew a little coordinate grid in there, here is a horizontal line, flat, straight across. Let's actually, to help us with this, let's give it some coordinate pairs so we have something real to talk about. All right, this coordinate pair on the right side is over 1, let's say it's over 1 up 2. So over 1 up 2, so that coordinate pair is 1, 2. The coordinate pair on the left, let's call that one -2, +2. So to the left 2, up 2. All right, are we surprised here that these two coordinate pairs on this flat line have the same y coordinate? Are we surprised that they have the same height? I am not surprised. Reminder, your y coordinate is your height. Every single coordinate pair on this line is going to have the exact same height because they're on a horizontal line. See how that happens here? So they all have the same y coordinate. Let's calculate the slope of this line between these two coordinate pairs that we identified. So reminder that your slope is rise over run. So we're going to do rise divided by run. All right, our rise is we are going to take our y coordinates and subtract them from each other. How far away? What's 2 minus 2? 0. Those y coordinates are 0 units apart because they are the same y coordinates. All right, what about our x coordinates here? If we do 1 minus -2, we are left with +3. Subtracting a negative makes it go up. We're left with 0 divided by 3. 0 divided by 3. Any 0 divided by a number will always give you 0. So you just found out here, you calculated that the slope of a horizontal line is 0. Dun, dun, dun. Let's do a similar process to 3B. Explain why we use the term undefined to describe the slope of a vertical line. So a vertical line, straight up and down. Let's draw a sketch and give us something tangible to analyze. Whenever I come across something in math and I have no idea what they're talking about, I draw a picture. It really does help. All right. Pretend that's a perfectly straight vertical line there. And let's give it some coordinate pairs so we can actually do some calculations. So let's pretend it's over 4. And let's find 2 points on this line here. There's a coordinate pair and there's a coordinate pair. Let's call that first one up 1. Oh, see how it keeps disappearing. Well, great. All right. And then let's call that other one up 3. All right, actually calculate those coordinate pairs from our sketch. So over 4, up 1. What do you predict is going to be the same with these two coordinate pairs? Are the x coordinates going to be the same or the y coordinates going to be the same? Over 4, up 3. Good. So our x coordinates are going to be the same because that determines how far you go right and left. And if these two coordinate pairs are on the same vertical line, that means that we've gone over the same amount. So notice any two coordinate pairs you find on this line, they're going to have the same x coordinates. Let's calculate the slope now. So reminder that your slope, always rise divided by run, meaning the difference of your y values divided by the difference in your x values. So let's calculate our rise. For our two coordinate pairs, how far away are they? If you want to start at this top coordinate pair and go to the bottom coordinate pair, we could do 3 minus 1 to figure out how far apart they are. So they're 2 units apart, the two coordinate pairs we're using. How far away is their run? So x coordinate was 4, and then it's 4 again. 4 minus 4 is 0. The run is 0. We're dividing a number by 0. Has anyone ever told you in math you can never divide something by 0? Because division means to put something in groups. So what this is saying is you're putting something in 0 groups. If you take your calculator and you crunched it, you would actually, in fact, I want everyone to do this right now. Take your calculator, do 2 divided by 0. Pause this if you need to go find a calculator. You can also use Google. You can go to Google. Do 2 divided by 0. Press enter. I'm using a graphing calculator and it says error. You cannot divide by 0. My iPhone calculator. If I do 2 divided by 0, okay? 2 divided by 0. What? Error! You cannot divide anything by 0. Technically called undefined. Which is why we say the slope of a vertical line is undefined, because technically your run is 0, meaning there's no difference in x coordinates, which means we cannot divide by 0, therefore it is undefined. Dun, dun, dun. All right, so this was slope of a horizontal line and slope of a vertical line. So for number 6, describe what the graph of the equation y equals 50x plus 125 will look like. Reminder, you can tell a lot about a graph by looking at it in in y equals mx plus b form. B is holding the place for your y-intercept. So what does it mean if you have a y-intercept at 125? Where is that graph going to start? It's going to start above the origin or below the origin? It's going to start above the origin. And what does this 50 out in front of the x mean? This is your slope. Is our slope going to increase at a constant rate, or is it decreasing at a constant rate? It is increasing, 50. So reminder, your line is going to increase from left to right because it has a positive slope. So what is this graph going to look like? Well, it's going to start at a point that is above the origin, and it's going to increase from there. That's what we know. If they ask you to actually graph it, then you want to set up your x and y axes like we did on that previous one. But this one is just asking, describe what the graph will look like. And that's what we've done. So for the rest of the problems in this lesson, do them along with your workbook. Check your answers with the answer keys. And then your job, if you are not sure how to get a correct answer, is to get help. So you can reach out to your teacher for help, or you could go to tutor.com, connect with a free tutor on your launch page. Tutor.com, bright orange app on your launch page that you go to log into your Canvas classes. All right, happy mathing!